Okay, let's wait for another 5 minutes so that everyone already into the meeting room. Okay, can we start now? Okay. Hello, can everyone hear my voice?
Okay, okay, doctor.
Yes, doctor.
Can.
Okay, doctor.
How doctor?
Yes, doctor.
Surya.
What happened to this meet interface?
Yeah, why it is like this?
Salah muntun.
Hmm?
Like tu. Tanpa ramai.
Saya rasa kena cancel presentation tu presentation boleh.
Presentation? Stop sharing. Okay? Is it okay now?
Yeah.
Right now.
You only can see your face.
Okay, doctor.
Okay, huh? Okay, can I share the screen now?
Yes,
how-
doctor.
Let's try to share the entire screen. Okay. Before that, I hope everyone can mute your microphone. Can everyone mute your phone? You can on your video, but please mute your microphone. Okay? Okay?
Okay, okay.
Okay, good. Now you can hear my voice clearly, right? Okay? Okay, okay, let's go to where we stopped before, which is on page 177. This is the book by Anton. You can refer to your book if you cannot see my screen. clearly. Okay, so let's go to example 5. Okay, so this is by using chain rule. There are two somehow when we deal with this kind of problems, like in this example A, we can use chain rule. Chain rule is when you define another variable u as the sub variable in the expressions. Okay. But then actually this book also introduced generalized derivative formula. When we are not gonna go through this, you can read by your own. But now we're gonna use chain rule, the one that we have learned before, in order to solve all the examples. Okay, so let's look at example 5 here. So we have d dx sine 2x. So how are we gonna solve this? Okay, sine 2x. So we have d dx, okay, d dx for sine 2x. For chain rule, you have to express this 2x as another variable. You already know the derivative of sine x. You know that d dx for sine x is equal to cos x. So this is well known. You already know this before, but you don't know, let's say you don't know what is the derivative of sine 2x. Okay? So in this case, you have to represent 2x as a new variable. So let's say you denote the 2x as u. So let's denote this as 2x. So u is equal to x. And you represent y as sine 2x. Okay? So it means that your y here is also equal to sine u. Okay? And then by using chain rule, the purpose is to find dy dx. And the dy dx, by using chain rule, it is dy du multiply with du dx. Okay, so what is dy du? You differentiate y with respect to u. It means that this is the expression that you have to look at. You differentiate y with respect to u. You neglect this thing. You don't have to see this sine 2x. Okay, so if you differentiate y with respect to u, you will get cos 2x. So this one is, sorry, cos u. This one is cos u. And du dx is from here. You differentiate u with respect to variable x. So you will get 2. So this one will give you du dx is equal to, so this one is equal to 2. And you know that this is the derivative of u with respect to x. So we expect that the final answer will be in terms of x instead of u. So you have to substitute u equal to 2x back in this expression. So it will be 2 cos 2x. Okay, so this will be the answer. Let's check. Okay, so this is the answer, the same one. Okay. This one give you the same answer. Okay, so let's look at B. For B, tangent x squared plus 1. Okay, so you have y equal to tangent x squared. What is the question? X squared plus 1. Okay, y is equal to tangent x squared plus 1. And then what is your previous knowledge in terms of tangent? The derivative of tangent, it will be secant squared x, isn't it? So if you have y equal to sorry, So if you have y equal to tangent of x, okay, your dy dx will be equal to secant squared x. So this is your pre-knowledge. You already know this, isn't it? We're gonna use this information in order to solve this question here. Okay, so firstly, you define u as x squared plus 1. So the equation y equal to tangent of x squared plus 1 can also be written as tangent u. Okay. What happened to my Microsoft Office? Is it good now? I hope so. Let's go to okay. Tangent of u. Since you represent u as x squared plus 1. And then now we know that we want to use chain rule. So the dy dx is equal to dy du multiply with du dx. So here you differentiate y with respect to u. So it means that it will be secant squared u from this the pre-knowledge that you already know. So this one is y equal to tangent of x, and you differentiate y with respect to x, you get secant squared x. What if you have y equal to tangent of u? You have to differentiate y with respect to u, so it will be secant squared u. Okay, is it clear? I hope it is clear. Okay, so this one will be secant squared u, and then the du dx is from here. You differentiate u with respect to x. So the du dx is equal to 2x. Okay, so you write it here, 2x. And then you know that the final answer should be in terms of x. So you replace u, substitute u as x squared plus 1. So the final answer will be secant squared x squared plus 1, and then you multiply everything with 2x. Okay, so this is the final answer. So let's compare with the solution from the book. 2x secant squared x squared plus 1. So 2x secant squared x squared plus 1. So this is the solution. It's the same. Okay? Is it okay?
Okay, Doctor.
Yes.
Okay, Doctor.
Okay, Doctor.
Okay, now let's go to the third example. The example is a square root of x cubed plus cosecant x. Okay, square root of x cubed plus cosecant x. So this is one of difficult question. Okay, so the y is equal. Oops. Here. So y is equal to square root of what? Square root of x cubed plus cosecant. X cubed plus cosecant of x. So this is the question. Okay. Am I right or not?
Yes.
Okay, good. Okay, now
Yes.
we are asked to find the derivative of y with respect to x. Okay. Okay, now before that, we have to represent some of the new variable so that we can apply the chain rule. Okay. How we gonna do this? Okay. So this one is equal to x cube plus cosecant x to the power of 1/2. Okay. And then can you represent the whole thing, the inner expressions as u? So let's do it. Let's try to do it. Okay, I'm not sure if this is doable or not, because some expressions it is quite difficult for you to differentiate by using chain rule. Not everything can be solved by chain rule. Okay. So u is equal to x cube plus cosecant. I think this is correct. CSC, not CSX, right?
CSC.
Yes.
Okay. CSCX. Okay, so we introduce u as x cube plus cosecant x. Okay, so it means that your y will be u to the power of 1/2. Okay, and then the dy dx is equal to dy du multiply with du dx. Okay, so now what will be the dy du? So this is by using our rules. Okay, you can solve dy du. You differentiate y with respect to u by using our rules. Okay, so if y is equal to u to the power of 1/2, your dy du is equal to 1/2 u to the power of negative 1/2. So this is your dy du. Okay. And then what about du dx? So the du the function u is this one. Okay. So du, well, what is the you differentiate u with respect to x. So this one you can solve by using power rules. It will be 3x squared. What about cosecant? What is cosecant? 1 over sine, isn't it? Cosecant is 1 over sine, right? 1 over cosecant. 1 over,
Yes.
wait, I think. 1 over sine is equal to cosecant. What about 1 over cos? 1 over cos is secant, right? Okay, so this is correct. 1 over sine of x. So you have u. So you have u equal to x cubed plus cosecant of x. Okay. So this one for the cosecant of x, it is equal to 1 over sine of x. You want to differentiate this part here. Okay. So let's denote this as another variable. I'm not sure if I denote this as one variable and this one as another variable, I'm afraid you will get confused with the chain rule. But let's try this. Okay, so let's denote this as r plus q. Is it okay? So our cosecant of x is represented as q, which is equal to 1 over sine x. We want to find the derivative for q, derivative of q with respect to x. So we want to find the dq dx. Okay, and how you gonna solve? How you gonna find this derivative here? It must be from quotient rule. So quotient rule, you represent u as the numerator and the denominator as v. But in the previous function, we already denote u as this one. So we have to denote this as another variable. Let's see, try, we have R, we have Q here. What else? What about S? S and, can we try S? Okay, S and T. Is it okay? What about T? Okay, S and T. So the numerator as S and denominator as T. And the dq dt, dq dr, dx, okay, is equal to from the chain rule, from the quotient rule, it is S prime T minus T prime S divided by T squared. So this is quotient rule. Okay, maybe you are familiar with the previous formula that use U and V, but somehow we cannot use U as we already use U for another function. So that's why I use S and T. Okay. Okay, so this one, you differentiate S with respect to X, you got 0. Okay, 0. So you differentiate a constant. And then you multiply with T, so your T is sine X, minus T prime. T prime is you differentiate X with respect to X. You differentiate sine X with respect to X. And you get cos X, okay? And you copy S. S is equal to 1, okay? And you divide everything with T squared. So you divide everything with sine squared X, okay? Sine squared X. So the answer here is negative cos X divided by sine squared X. So this is dq dx. Okay, we already have the solution for this part here. So this one is easy. We can get from the power rules. So the answer for du dx is equal to negative, this part first. So 3x squared, okay, plus the derivative of cosecant. So this one, okay. So it will be minus. It should be minus here. Minus cos x divided by sine squared x. Okay, so this is du dx. Okay, so now let's substitute this du dx into this. Into this one. Okay, you substitute everything that you have obtained before into this one. And what about dy du? Dy du is easy. It's from power rules. So dy du is 1/2 u to the power of negative 1/2. It is this one. So dy du is already obtained here. So both you substitute, then you get the answer for dy dx. So that is how you solve the derivative of a function y. Okay, any question? Boleh ke?
Boleh.
Boleh ya?
Boleh. Tengah salin.
You don't have to copy. This meeting is recorded. I will share the link later. Okay?
Okay. Okay, Doctor.
Alright, Doctor.
Sorry? Okay, okay, now let's continue with example D. Okay, so example D is easier than the example C. Okay, x squared minus x plus 2. Okay, so the question is y is equal to x squared minus x plus 2, and everything is taken to the power of 3 to the power of 4. Sorry, 3 over 4. Okay, 3 over 4. And we are asked to find the dy dx. Okay, now, what will be the u? We want to use chain rule. What will be the u?
X squared
Inside the bracket.
minus x plus 2.
Yes, x squared minus x
Two.
plus 2. Okay, by chain rule, this is actually dy dx is actually equal to dy du multiply with du dx. Okay, you differentiate u with respect to x here, you get what? So the du dx is equal to 2x minus 1. Okay, and for the dy du, so since you represent the y as u to the power of 3 over 4, so this one can also be solved by using power rules. Okay, so this is equal to 3 over 4 u to the power of negative 1 over 4. And you multiply this with 2x minus 1. And then you have to substitute u as x squared minus x plus 2 for the final answer. Okay, so this is our almost final answer. So basically, this chain rule is very easy for you to use. Okay, and not only easy, it is also one method that is very systematic. Okay, because you can see clearly what is what is u, and what is x, and what will be the representation of dy dx. Okay, in terms of the derivative of u and x. Okay. Okay. Now, okay, I think we solved that. Try to solve P at home. Okay, if you don't know the derivative of cos x, you can use quotient rule, because cos x uh is cos x divided by sin x. Okay, and then once you know that the cos x is equal to cos x divided by sin x, you can straight away use quotient rule. Okay, obviously you still have to use product rules for x to the power of 5 and cot x. Okay, is it okay? Okay, can we have like 5 minutes break for you to solve solution E? And maybe I will pick one person to complete the solution. Okay, 5 to 10 minutes. Okay, because this is not an easy question. Okay, good. Okay, anyone want to share your answer? Is it doable or not?
Yes, it is. It is doable, but I'm trying.
Sorry?
It is doable, but how am I supposed to present?
It's
Should I
doable,
present?
but
No, it is doable, but I'm trying to think of a way to present my answer.
okay. Do you need more time? Like another 5 minutes?
Yeah, sure. Because I need to type it out my answer. Yeah.
Okay, any volunteer to share your working? Anyone want to share?
Saya, Doktor.
Okay, can you please present? I think I have to stop presenting first so that you can start presenting. But how you gonna use your presentation? Like how you
I'm going
gonna?
to present through Microsoft Words, though I still need to type it, but it's okay. We can do it along the way.
Can you share your working? Can you snap your working to WhatsApp so that I can download and show it here? Is it okay?
I guess you can do that.
Okay. Good. Share. Snap your work,
Okay.
and then I can download from WhatsApp. Okay.
Oh, sekejap. I've shared it on WhatsApp, but I don't know if it's clear or not.
But you use chain rule, right?
Yes, chain rule.
Okay, good. It's not clear. Obviously, it is not
Yeah,
clear.
I'm typing my answer on Microsoft Word right now. So if I may,
Okay, I give you
share
some
my screen
time
to you.
for you
Okay.
to type.
All right.
This is a good tools for teaching and learning. I have here, if you can see here, this is a tablet board. Okay, it comes together with a pen. Okay, before I always use my what we call this, my laptop as a tablet, because my laptop is also a tablet. This laptop comes together with a pen as well. But once you have to do like meeting, teaching and learning online like this, it is easier if you have a tablet board with you. Okay, so it works just like a tablet, but somehow for the original tablet, the screen will be your board, but this one, it has another board. Okay, and this is not expensive. This is China brand. It is Huion, Huion. You can find in Shopee. It cost me less than 200 ringgit. Okay, in order for me to write down on PDF file as well as Word file. For the PDF file, I have to download Foxit Reader. I'm not sure about other PDF reader, but I use Foxit Reader. And here, there's a comment icon here, and this is pencil. I can write it over here, like this one. If I want to draw something, or maybe I want to write it here, U equal to something, and just use this icon pencil. And this one is eraser. The same for Word. For Word, we have inking. So for Word, we have the pencil icon in review, I think. Okay, so you click review, and this one start inking. So this start inking is actually pencil, consists of pencil and eraser as well. Okay, so this is how we use tablet board. It cost me less than 200. Okay.
Mhm.
Just sharing with you because some of you might be interested with this because you have a lots of assignments that you have to use like video presentation and something like that. Okay.
Okay.
Just need one. Okay, Is it okay now?
Okay, jap lagi sikit je.
Okay.
I just need to finalize my final answer.
Okay.
Rasanya. Alright, rasanya saya dah I'm ready. I think I'm ready.
Okay. So I stop presenting and you take over. Okay.
Alright.
Is it okay?
Okay.
Okay.
Okay, can you guys right now I'm presenting to everyone. Can you guys see my screen right now? Nampak, eh?
Yes.
Okay, okay.
Okay. So the question is, alright, it is given that the y is equals to 1 plus x to the power of the tadi soalan dia. Negative 8, okay. Typing error there. My bad. Right. Okay. So alright, the question is y is equals to open parentheses 1 plus x to the power of 5 cotangent x close parentheses to the power of negative 8. And the question wants you to differentiate these particular functions. So first thing that we need to do is let u is equals to this, the inside of the parenthesis. So that means let u equals to 1 plus x to the power of 5 cotangent x. All right. So you will get u to the power of negative 8. Everything's clear so far, yeah?
Yes.
Okay. And from there, we want to differentiate y to the respect of u. That means you will get dy over du equals to negative 8 u to the power of negative 9. All right? Okay. From u, we all know that u is equals to 1 plus x5 cotangent x, right?
Yeah.
Yep.
Okay. Now, that we can simply differentiate, find the derivative of 1, which is equals to 0, right? But we cannot simply find the derivative of x to the power of 5 cotangent x, right? Okay. So from there, we only take this part of the u and we broke it down into two. As for in my case, I broke it down. Let x to the power of 5 equals to a, and cotangent of x is equals to b. Right? Okay. From there, okay. From there, we want to find the derivative of a and the derivative of b. So from here we can simply find the derivative of x to the power of 5, which is 5x to the power of 4. And here, cotangent x here, the derivative of cotangent x is equals to negative cosecant squared x, right? Based on the book lah, ataupun siapa yang hafal the derivative of cotangent x is equals to negative cosecant squared x.
You memorize, you can get from the quotient rule.
Okay.
Cotangent of x is equal to cos x divided by sin x.
Yes.
Okay? It means that you define u as cos and v as sin x and get it from the quotient rule. But it is okay. The answer is correct. B prime is equal to negative cosecant squared x. But the later line, which is by using chain rule, is not correct. Actually, you use product rule. That one you use product rule.
Oh, product rule. Sorry.
Okay.
Yes, product. Okay, my bad. So by using product rule, we know that a prime times b plus b prime times a. So we just plug in our, we already have our a prime, b prime, as well as a and b. So from there we just plug in the numbers according to the product rule punya formula, and you will get 5x to the power of 4 cotangent x minus, because here we have negative cosecant x. When you expand it, right, you will get negative x to the power of 5 cosecant squared x. Right. Now that we have our derivative for x to the power of 5 cotangent x, we can just find our dy dx, which is dy du times du dx. So from there we plug in our numbers. So our u is from here. Our u is 1 plus x to the power of 5 cotangent x. So we just plug in there, substitute our u here, right here. And then we expand it. I choose to expand it this like negative 8 times to this one, because this is a bit complicated for me to expand it, right? So my final answer is open parenthesis 1 plus x to the power of 5 tangent x close parenthesis to the power of negative 9 times, I forgot to put the dot here, sorry.
The second last line is already the final answer for me. You don't have to simplify or expand that. Okay?
Oh, okay.
I already accept the second last line as the final answer.
Okay.
Okay, good. So thank you very much, Muhammad Amiruddin. Okay, good.
All right.
Okay,
So,
good.
okay. So I'll stop sharing right now, yeah?
Okay, good.
Is there anyone want to ask regarding
Any
to this
question?
question?
to Muhammad Amiruddin?
No, understand.
No
No, no.
understand?
Yes, I'm understand.
Faham ke tak faham?
Faham.
Oh, okay. Alright. So I will be stop sharing my screen, yeah?
Okay. Thank you,
Alright.
Amiruddin.
Welcome.
Okay, let's continue with example 6. Okay. Example 6, we have sine of square root of 1 plus cos x. So it means that you have to denote the whole thing here as u. Okay, so let's try it. Okay, sine square root of 1 plus cos x. Okay, let's try to do it. How can I add blank page at the end of the of this page? It should be insert blank page, isn't it? Somehow it insert it here. So whatever it is, let's save this one first. Okay. I think before that, I have to start present now. Okay.
Right, Doctor.
Okay. The question is sine 1 plus cos x, square root of. Yes. So the question is sine sine square root of what is it again? 1 plus cos x. Okay. So 1 plus cos x. Okay. So you denote u as square root of, sorry, not with the square root. You can denote u as this one first. Is it okay? Wait. So if you denote u as the whole thing, 1 plus cos x to the power of 1/2, you might want to denote the inner expressions as another variable, let's say v. So v is 1 plus cos x, okay? So you have two additional variable here. So the original one is y, and you have u and v. So your dy dx, how can I add an empty page after this one? How I'm gonna go to the next page?
Go to the insert tab.
Insert
A
page.
blank page. Blank page, yeah.
Blank page. It's not working. It
not
adds to the page before that.
Alright, step.
Page break, Doctor.
Page break.
Page break.
Sorry?
By using the page break. Below the blank page.
What is page break?
Okay, at the insert tab.
You click on the last page first, and then you click the break page.
under the blank page.
Okay, good. Okay, dy dx. Okay, so dy dx is equal to dy du multiply with du dv multiply with dv dx. So this is chain rule. Okay, so your dy du, so you represent u as this one. So it means that the y is equal to sine. Okay, not working again. What is not so stable with this writing? I have to use OneNote. If you know the software, it is free software, but next time maybe. Okay. So sine u. So y is equal to sine u. Okay, and then the u here, if we represent v as 1 plus cos x, means that your u is v to the power of 1/2. Okay, so from here, the dy dx is equal to dy du. In this case, you differentiate y with respect to u and get cos u. Okay, cos u. And then you have du dv. So this one is du dv. Your u is equal to v 1/2. So in order to differentiate u with respect to v, you use power rule. So it will give you 1/2 v to the power of negative 1/2. And then for dv dx, it comes from this one. It will give you what? Negative sine x. Because if you differentiate constant, it will give you 0. So the answer for this is negative sine x. So everything should be written in terms of x. You have to substitute this u in terms of x and this v in terms of x. So the u is this one. The u is this one. Okay, the whole thing in terms of x, and this is your v in terms of x. Okay, so is it clear? Okay.
Yes, it's clear.
Okay, good. Okay, next. I think you can do for B. Okay. We finish this chain rule topic, and let's have like 5 minutes break before we continue to another chapter, which is topic in differentiations. Can we take like 5 minutes break? 5 or 10? You want 5 or 10
Sure.
minutes break?
Up to you, Doctor.
5. Okay, good.
Doctor,
Yes?
there are still ada kawan saya nak try masuk join session ni sebab tadi dia dah join dah but accidentally disconnected sebab internet dia tak stable.
Ask him to request to join.
Okay. Alright. Oh, dah masuk dah. Okay.
Dah masuk?
Dia kata dia dah masuk dah.
Dah lebih 5 minit bagi tahu saya. Let me know once the 5 minutes is over. Okay?
Start pukul apa tadi? Titik 5 tadi pukul berapa?
Okay, can we proceed with the next topic?
Yes.
Yes, yes,
Okay,
yes.
the next one is implicit differentiation. So this implicit differentiation is very important because not all expression can be simplified such that y is moved to the left hand side and the other expressions are moved to the right hand side before you differentiate. So if you look at here, xy is equal to 1, you know that for this equation here, it is easy for you in order to make y as the subject of the equation. When I say subject, means that the y is located to the very left of the equation and the other expressions are transferred to the right hand side. Okay, so this one is easy. The y is equal to 1 over x, isn't it? Okay, but not all equations are as that easy. It could be we have let's say you have trigonometric function like x multiply with cos y equal to 1. Then it might be a bit difficult for you to make y as the subject, even though it is doable in that case. But it is not as easy as xy equal to 1. For that kind of equation, it is necessary for you to use implicit differentiation. Okay, so let's try to look at this method. Okay, so let's say you have xy equal to 1. Okay, you don't have to transfer y to the y to the left hand side and the other expression to the right hand side so that the y be the subject of the equation. You don't have to do that. Okay, so let's say you try to do it. Okay, so you get y equal to 1 over x, and this one is also equal to this one is also equal to okay, this one is also equal to x to the power of -1. And you can use power rules and get dy dx is equal to negative of x to the power of -2. Okay, so this is the answer for the dy dx. Okay, so that is the conventional way of finding the derivative of y with respect to x. So let's say you don't want to use that that way. Okay, you want to use implicit method. Okay, the implicit method is you have to differentiate both sides of the equation. Okay, so you put here dy dx xy, and for the right hand side you also have to put dy dx. Okay, sorry, not dy dx, d dx of 1. Okay, and then the xy here is in terms of product. So it means that you have to use product rules. Okay, so one is denoted as u, another one is denoted as v, and you apply product rules. Product rule says that it will be in terms of u prime v plus v u prime v plus v prime u. So that is product rules. Okay, but we have to be careful here because this is dx. Okay, and another one is dy dx. Okay, so let's look at this first. So one is how I'm gonna explain this so that you can understand. So let's denote it as u equal to x and v is equal to y. Okay, so d dx for u multiplied with v is equal to u prime v plus v prime u. Okay, so u prime u with respect to x. You differentiate u with respect to x. Means that you differentiate x with respect to x. Okay, so you will get 1. You will get 1, and then you copy v. So the v is equal to y. Okay, so 1 multiply with y plus v prime. You differentiate y with respect to x. So means that you have to copy dy dx.
dy dx.
Is it okay? And then the u, you just copy x. U is equal to x. So that's why you get y plus dy dx multiply with x.
X.
So this is the left hand side. Okay, and for the right hand side, you differentiate a constant with respect to x. Obviously, you will get 0.
0.
So that's why you have x dy dx plus y equal to 0. And from here, you can make dy dx as the subject because this is what we want to find. And the answer is negative y divided by x. And obviously, you can substitute what is y. Okay, y is 1 over x. If you substitute, you will get the same answer as when you use the conventional way. Okay? Is it okay? Any question? Okay, ah? Any question? Lydia?
No. Okay.
Okay, ah? Okay, ah, Lydia? Good.
Yes.
Okay, okay, let's look at example 2. Okay, example 2 is 5y squared plus sine y equal to x squared. Okay, so like before, we want to use implicit differentiation. Why we want to use implicit? Because it is not easy for us to make y as the subject for this equation, isn't it? It's too difficult for us to make some mathematical manipulations such that the y be the subject of the equation. Okay? Okay. For the implicit, we have to differentiate both sides. Okay, so you differentiate the left-hand side as well as the right-hand side. You differentiate 5y squared with respect to x. And then you differentiate sine y with respect to x. The key is actually you differentiate this if this is too difficult for you because you are not familiar with how you differentiate variable y, you have to note that whenever you differentiate something or any variable y, it will be just the same rules as before as if you differentiate a variable x, but what is the additional things that you have to remember is you have to write dy dx at the back of the expression. Okay, so let's say you want to differentiate y squared. Okay, so if you differentiate y squared, if you differentiate x squared, you will get 2x, isn't it? If you differentiate with respect to x. Okay, but in this case, it will be 2y. 2y, and after that, you have to write dy dx. Okay, but for 2x, it is fine. Oh, sorry, for x squared, it is fine. Okay, it will give you x because for the right hand side here, this one is also 2x multiply with dx, which give you 1. So that's why we don't have to write dx here. But for those with the variable y, we still have to write dy dx because it is not cancelled. The denominator and somehow the derivative of y with respect to x is not cancelled. Not like if you differentiate x with respect to x. Okay? So that's why this one give you y dy dx. What about this one? You differentiate sine y, you will get cos y, and then you write down dy dx. Okay? Once you get this one, this expression here, this equation here, you can make dy dx as the subject of the equation. Okay? This is still not final. The final one is when you write dy dx as the subject. Okay? Is it okay?
Yes.
Okay or not?
Yes,
Okay, good.
yes, yes, yes.
Okay, good. Okay, now example 3. Example 3, use implicit differentiation to find d squared y dx squared if 4x squared minus 2y squared is equal to 9. So in this case, you see that if we want to make this as a subject, it might give you like plus minus square root of something. So we don't want to get involved with that. So we want to use implicit instead. Okay. So 4x squared minus 2y squared. I think let's switch to OneNote. OneNote. Okay. 30. Okay, this one. Okay, good. Okay, so 4x squared minus 2y squared. Okay, so we have 4x squared minus 4y squared. Sorry, 2y squared equal to 9. 2y squared. Oops. So 2y squared equal to 9. So for the implicit, we have to differentiate both sides. So d dx of 4x squared, okay, minus d dx of 2y squared, okay, equal to d dx of 9. Okay, so for the right hand side, it is already 0. So it is a constant. For this one, this is with respect to x. So it will give you 8x, okay? But for this one, it will be 4y, and then you write down here dy dx, okay? So the final answer will be when you make dy dx as the subject. So you transfer everything to the right hand side and get negative 4y dy dx is equal to negative 8x, okay? So your dy dx is equal to negative 8x divided by negative 4y, which gives you 2x divided by y. Okay, so the answer is negative 2 2x divided by y. Okay, so this is the answer. Okay, but the questions ask you for what? The second derivative. We have to find the second derivative of y with respect to x. Okay? Okay, so we already have dy dx, which is this one. So now we want to use quotient rule. So we have dy dx is equal to 2x divided by y, which is our u is equal to 2x, and our v is equal to y. Okay? So from the quotient rule, d squared y dx squared is equal to u prime v minus v prime u divided by v squared. Okay? So u prime here is you differentiate 2x with respect to x. Okay? With respect to x, which give you, and then you copy v. In this case, your v is equal to y. So you just copy y. And then minus v prime. So your v prime means that you differentiate y with respect to x. So it gives you dy dx. Okay? If you differentiate y with respect to y, you will get 1. And then you copy dy dx. Okay? And then you multiply with u. So your u is 2x. Okay? So here it is 2x. This is 2x, okay? You have 2x here. Okay, and then you divide everything with v squared. So our v squared is y squared. So the answer is d squared y dx squared is equal to 2y minus dy dx. Our dy dx is 2x minus, divided by y. Okay, so it will be 2y minus dy dx is 2x divided by y. Okay, 2x divided by y, and then you multiply with 2x. Okay, you multiply with 2x, and then you divide everything with y squared. Okay, so this is your answer for d squared y dx squared. Let's compare. Okay. They get negative 9 divided by y cubed. How do they get that? Before that, we have 4x squared minus 2y squared equal to 9. Can we simplify this? How can we simplify this? Okay. So, this one is equal to 2y minus 4x squared, okay? And then you divide with y. Okay. And then here you have y squared. And this one you divide with y squared as well. Okay? If you simplify, you get 2 divided by y. And this one, you get what? 4x squared divided by y cubed. Okay, we have to make use of this. 4x squared minus 2y squared equal to 9.
Doctor,
Yes?
I think we need to times y. We need to cancel the y. 2x over y, so you need to cancel y.
And so y, which y?
The second, the 2y.
This one? I
Sorry.
already cancelled. I already cancelled the y here.
I think from the answer before.
This one?
Yes. 2y minus 2x over y, right? So we need to cancel y. So we need to times everything with y.
You need to times everything with y. So it means that you times y here. You times
There
y
are
here.
2x over y, right?
This one like this.
We need to times y. Yes.
Like this. So if you do it like this, you can cancel this one. It still give you the same answer. So wait, 2y. Is this one is correct or not? 2x divided by y is correct, right? And then we have dy dx equal to 2x divided by y equal to u divided by v. And then you have v squared y dx squared equal to u prime v minus v prime u divided by v squared. U prime is 2. The v is y minus v prime. So your v prime is dy dx. And then you multiply with u. So 2x. And then you divide everything with y squared. It seems correct. Right.
Yes, it's correct.
Sorry, I cannot hear. And then 2y minus 2x divided by y.
You need to multiply
Multiply?
the bracket first. Yes. 2x times 2x is 4x squared over y.
4x squared over y. I already write it here. 4x squared divided by y. I have 2 hours meeting starting from 8, and after that I have class at 10 to 1. So I cannot think much. Okay, you have to help me. Okay? 4x squared. I think this is correct. 4x squared divided by y. Or y squared. Okay, whatever it is, we have to make use of this. 4x squared minus 2y equal to 9. Okay, so let's write it. 4x squared minus 2y squared equal to 9. Okay, let's think on how we can simplify this by using this equation here. So we already have like 4x squared here. Okay.
Multiple 2 over y with y.
Okay, I know.
Square.
This one you should not separate this like this. It should be 2y squared divided by y cubed minus 4x squared, okay, divided by y cubed, okay. So if we write it in terms of this, it means that the whole thing for the numerator is actually equal to negative 9. So the answer will be negative 9 divided by y cubed. Betul tak?
Betul.
Okay, good.
Betul.
Yes.
Okay, good. So this is the answer. Okay, next, example 4. Example 4, find the slope of the tangent line to the curve at the point 2, -1 and 2, 1. Okay, the slope of the tangent line. So when we say slope of the tangent line, it's always deal with the derivative. Okay, so what is the derivative of this equation here? What is dy dx for this equation? Okay, so we have y squared minus x plus 1 equal to 0. Okay. Y squared minus x plus 1. Y squared minus x plus 1 equal to 0. Equal to 0 at point 2, -1 and 2, 1. 2, -1 and 2, 1. Okay, so this is what we want to solve. Okay, so like before, for the implicit differentiations, you differentiate left hand side and you differentiate right hand side. So d dx for y squared minus d dx for x plus d dx for 1 is equal to d dx of 0. Okay, so for the derivative of y squared with respect to x, it will be 2y, and after that you write down dy dx. Okay, for dx it will give you 1. 1 multiplied with dx which is cancelled. So that's why you have just 1. Okay, plus d dx for 1. It will give you 0 because it is a constant. It's the same for your right hand side as well. It will give you 0. And now you have to make the dy dx as the subject. Okay, so dy dx is equal to 1. Okay, divide by 2y. Okay, 2y. Okay, and then you substitute in what? You want to find the slope of the tangent line for this coordinate, 2, -1 and 2, 1. Okay, so 2, -1. You substitute what coordinate? The coordinate of y. So the y is -1. So the first one, the dy dx is equal to 1 over 2 multiplied with -1. Okay, it gives you -1 over 2. Okay, sorry, -1 over 2. Okay, so that is your dy dx for the first coordinate here. And the second coordinate is 1. So it means that the dy dx, okay, so this is 2, 1, and another one is what? 2, -1. So 2, -1. Okay, so for 2, -1 is this one, and for the dy dx for 2, 1, it can be written as 1/2, right? The answer is 1/2 and -1/2. Okay, so the answer is 1 is -1/2 and another one is 1/2. So that are the slope for the tangent line at x equal to 2, and another one is at x equal to 2 as well. For coordinates 2 and 1 and 2 and -1. Okay, I hope it is clear. Okay, let's continue. But I think this is doable for you to do at home. So let's do it at home. Okay, let's continue with another topic, which is derivative of logarithmic function. Okay, is it okay if we continue?
Okay.
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 Okay. Derivative, huh? So for the derivative, obviously any derivative formulas that you have learned before, like power rules and trigonometric function, like how do you get the derivative of sine x, which is equal to cos x. The derivative of cos x is equal to negative sine x. It is because of this first principle. This is the first principle of the derivative. You get everything for the derivative from this formula. Formula limit h tends to 0 for fx plus h minus f of x divided by h. So the original formula is limit h tends to 0 f of x plus h minus f of x divided by h. You have seen this a lot, okay? And that is also for the logarithmic function, okay? So we have a lot of logarithmic functions. We have families. We call it families. Families of logarithmic functions. What is the difference between all these logarithmic function? Just the base of the logarithmic functions. Like you have seen a lot of log of x with base 10 during your secondary school, but after you come to the university, somehow you see ln x more than this logarithmic function. So ln x is actually logarithmic of x with base e. Okay, and the families of x, families of the logarithmic functions is for the logarithmic function of x with any base a. Any base a. A can be any constant. Okay, e is also a constant. It is defined by 2.71 something. You can press your calculator and check. Okay. E is not from the word the word exponent, but it is from the word from someone's name. It is Euler. Euler. It is a mathematician, a famous mathematician. Okay. Okay. From this first definition, the derivative of ln x is equal to 1 over x. Okay. For x greater than 0. Why x greater than 0? Because ln x is always defined for the positive side only, for the right hand side of x equal to 0 only. If you draw the graph of the logarithmic function, it will be something like this. It will always intersect at x equal to 1. Okay? The families of logarithmic function will have the same shape like this. It's always intersect at x equal to 1. But how it curve is depends on what base it is. Okay? So this is how the logarithmic functions looks like. Okay? As x tends to 0 from the right hand side, I'm talking about from the right hand side because there's nothing from the left hand side here. Okay? From the right hand side, then the function will tend to negative infinity. Okay, so the limit of f as x tends to 0 from the right hand side is equal to negative infinity. Okay, and then here it's written x greater than 0 because the function, the logarithmic function, is only defined for x positive. It does not define for the negative of x. Okay, so this is for ln x. The derivative of ln x is equal to 1 over x. But then for the general logarithmic function with base b, with the general base b, it can be written as 1 over x ln b. You just remember this formula here. Okay, you don't have to remember this one. But then if you substitute ln E, so when B is equal to E, ln E is equal to 1. So that is how you get 1 over X. Okay, is it clear? Is it okay? Okay, ah? Boleh tak?
Okay.
Okay,
Okay.
doctor, but I would like
Okay,
to
okay.
ask,
Okay, okay.
what page is
Okay.
that, doctor?
What page? 193.
193, because in the book that I've downloaded,
The yellow cover. The yellow cover.
193, because I couldn't
I'm using
find.
the yellow cover.
Okay, jap. 193.
Okay, ah? Okay, example 1. Find so this is the graph of y equal to ln x, and its tangent line at the points x equal to 1/2, 1, 3, and 5. Find the slope of those tangent lines. Okay, so we know that the dy dx, so the y is equal to ln x, and then the dy dx, okay, the dy dx is equal to 1 over x, okay, from the formula. And the questions ask us to find its tangent line at the point x equal to 1/2. The slope of the tangent line is given by this equation here, dy dx equal to 1 over x. So the dy dx at x equal to 1/2, x equal to 1/2 is given by what? 1 divided by 1/2. It is equal to 2. And this is the slope. The slope, maybe I can denote it as m. Okay? So this is the slope. The equation of the tangent line is a line. It's a straight line, which is always, since it is a straight line, it is always valid for you to use this equation. Y minus y1 divided by x minus x1 equal to m. So your m is equal to 2. What will be your y1? Okay? So the x is known, which is 1/2. x1 is equal to 1/2. So x1 is equal to 1/2. What about y1? Y1 is the coordinate of ln x whenever x1 is equal to 1/2. So the y1 here will be ln of 1/2. Okay, so this is the equation that you can get. Okay, so you can simplify this so that the y be the subject. The m is already known, which is equal to 2. Ada ke jawapannya? Where is the slope? Oh, the question only asks you for the slope, not for the question of the tangent line. So it stop here. So it should stop here. Sorry, stop here. The question does not ask you for the equation of the tangent line. If the questions ask you for the equation of the tangent line, then you have to use this formula. And you have to make y as the subject. Okay? Is it okay? Any question?
Okay, okay, okay.
Okay, Boleh, Okay, next. Next. Okay, you can try for x equal to 1, for x equal to 3, and for x equal to 5. I think someone anyone on the mic? Yeah. Okay, okay, let's continue with example 2. Example 2, find d dx ln x squared plus 1. Any idea on how to use, on how to solve this equation, this function? So the function is ln x squared plus 1. Any rules that you want to suggest?
Chain rule.
Okay, chain rule. Okay, it's correct. So ln x squared plus 1. So it means that you have to represent the u as x squared plus 1 and then apply chain rule. Okay, ln x squared plus 1. Okay, let's try to do it. So the y is ln x squared plus 1. I think we have done it before, or not? Not yet, huh? So let's denote u as ln, sorry, you denote u as x squared plus 1 so that your y is equal to ln u. Okay? And then you apply chain rule, which is dy dx is equal to dy du multiply with du dx. Okay? So the dy du is equal to, this is ln. So the derivative of ln u with respect to u will be 1 over u. And then you multiply with du dx. You differentiate u with respect to x. You get 2x. Okay? And after that, you substitute what is u. So the u here is 1 of is x squared plus 1. So it will be 1 over x squared plus 1. Then you multiply with 2x. Okay, so this will be your final answer for the dy dx. Okay, this is your final answer. Okay, next. It's quite complicated now. Example 3. Ln x squared sine x divided by square root of 1 plus x. How are you going to solve this? Okay, so for this question here, instead of using quotient rule or product rules, actually we use the
Chain rule.
not chain rule. This is the properties of the logarithmic function. What is the properties of the logarithmic function? For the power, it can be taken out in front of the ln. And then for the product, it is minus. It is summation. And then for the division, it will be minus. So if we look at the properties of the logarithmic function, this y here, okay, so let's say you have what? Ln x squared plus sine x, okay, ln x squared plus sine x, is it? Sorry, not plus, multiply. X squared sine x divided by 1 plus x. Divide by 1 plus x. Okay? 1 plus x square root. Okay, so this is your expression that you have to find the derivative. Okay, so let's denote this as y. So let's denote this as y. Okay, so you can simplify this, not simplify, expand this so that it is ln x squared. So for the product, it will be plus ln of sine x, and then for the denominator here, it will be minus. It will be minus of minus ln square root of 1 plus x. Okay, so it is from here. If we look at here, ln x plus ln sine x minus 1/2 ln 1 plus x. But how do they get 2 here? Is because ln x squared is equal to 2 ln x. Okay, so this one here is also equivalent to 2 ln x. Okay, plus ln sine x minus, and this one is square root of 1 plus x, which is equal to the power of 1/2. So it is 1/2 ln 1 plus x. Okay, so everything here is equal to y. So everything here is equal to y. If you denote everything as y, then this can be written as y. Okay, is it okay? Okay, then what we have to do next? What is the question one from us? The question want us to find dy dx. Okay, so the questions ask for dy dx. So this is your y. So the questions ask for dy dx. Okay, so you differentiate each of these. So the derivative of 2 ln x is equal to 2 1 over x. Okay, what about this one? Ln of sine x. How are you gonna solve? You have to use what? Chain rule, right? You have to denote sine x as a new function. Sine x as u. Okay, it will be ln u. Okay, so if you denote u as sine x, then your ln sine x will be ln u. Okay, so the d dx of ln sine x is equal to du dx. Okay, sorry, is this correct? D dx of ln x is equal to, sorry, so if you denote u as sine x, this is, wait, u is equal to sine x, ln sine x is equal to ln u. Okay, so this one, maybe you have to define this one as a new function v. Okay, we want to find the ln of sine x, which is dv. So this is dv dx, right? So this is dv dx. So your dv dx, okay, this is not correct. Okay, your dv dx is equal to dv du. Okay, so dv du multiply with du dx. Okay, so your v is equal to ln u. So you differentiate v with respect to u, then you will get 1 over u. Okay, and then du dx is equal to cos x. Okay, so the answer will be 1 over u multiply with cos x. So the answer will be cotangent of x. So this is the answer. So you substitute it here. Okay, so this is plus cotangent of x. Okay, what about this one? Once again, you have to use chain rule. Okay. Before that, can we check we compare the answer for this one? Is it correct? Okay, it is correct. Cot x. Okay. Okay, for this one, for the third expression, it is ln 1 plus x. Ln 1 plus x, okay? Ln 1 plus x. So ln 1 plus x. So let's say you denote this as, let's say r, okay? So you want to represent 1 plus x as q. So q is equal to 1 plus x, okay? You want to find the derivative of this, dr dx, which is equal to dr dq multiply with dq dx, okay? So ln 1 plus x is equal to r, where the q is 1 plus x. So it means that your r is ln of ln q, okay? So dr dq is equal to what? It is equal to 1 over q, okay? 1 over q, and dq dx is equal to 1. So the answer will be 1 divided by 1 plus x. So this is the answer for the expression 1 plus x. So the answer for this is minus 1/2 1 divided by 1 plus x. 1 plus x. So let's compare our answer. Okay. So it is 1 over 2 plus 2x. So it's because of this. Okay. So it is all correct now. Okay. I hope it is okay. Are you still with me?
Yes, yes, we're still with
Yes.
you.
Yes,
Yeah.
doctor.
I
Yes.
think it's better if we
Yes,
finish
doctor.
because we cannot do
Yes,
too much
doctor.
since it's already almost 5 p.m. now. So see you next week. Okay. Do you want to have the class on Friday, on each Friday? Because if I'm not mistaken, some of you have class on Friday. But my concern is if we have a class during weekends, then some of you might not get a free data, right? Is it true?
Yes. Yes. True.
Yes. Yes, doctor.
That is my concern. I'm okay with my data or my internet. But some of you might spend the free data. So that is why
Habis sekejap
I
ni.
try. And the free data is only up to 5 p.m., right? Is it true? From my understanding, you have like free data from 8 to 5. Is it true?
Yes.
Okay, so that's why we try to have our class on Friday. Even though some of you might have class, but I will share the recorded version after I upload in YouTube. Okay? Okay, so thank you very much.
All right,
See you
doctor.
next week.
Thank you.
Thank you,
Thank you.
doctor.
Thank you, doctor.
Okay.
Thank you, doctor. Take care and see
Thank you,
you
doctor.
then.
Take care.
Thank you, doctor. Bye.
Bye.
Thank you, doctor.
Thank you. Thank you. Bye-bye.
How do we stop recording?
Okay, doctor. Thank you.
Bye-bye.